Grade 12 Pre-Cal, lesson 7.4, the Pythagorean Identities. So what we're going to do is, if you make sure you have your formula sheet in front of you. So we're going to deal with, if you look at our formula sheet, we're going to deal with these ones right here. These are the Pythagorean identities, the sine, tan, and cotangent here, all that stuff. So have that in front of you, or beside you, sorry, when we're working through this. Okay, so first thing we want to do is we want to look at, is verify that the equation cotangent squared x plus 1 equals cosecant squared x is true for pi over 6. So basically what we want to do is we want to do left side and right side. We want to plug in pi over 6. And pi over 6 is in radians, right? So we set this up. Left side, cotangent squared x plus 1. Right-hand side, cosecant squared x. And let's plug in the numbers. So we're plugging in pi over 6, pi over 6. Now, what's cotangent? Well, tangent is sine over cosine. So cotangent is cosine over sine. So that breaks down into cosine pi over 6, sine of pi over 6, all squared. You can use your unit circle, figure out what those numbers are. Then we could do this here. We're going to take this divided by this, which means root of 3 over 2, times reciprocal, which is 2 over 1. We do the math. We end up with 3 plus 1. So we end up with the 2's reduced down. We end up with root of 3. Root of 3 squared is 3. 3 plus 1 is 4. Okay. Let's try the right-hand side. Cosecant, if you remember, it is 1 over sine. So 1 over sine squared pi over 6. So find out what the sine of pi over 6 is, which is a half. We're going to square it, which is a quarter. So we got 1 divided by a quarter, which is 1 multiplied by the reciprocal, which is 4. So we proved left side equals right side. So it's just a matter of working through the numbers and seeing if left side equals right side. Okay. B, use the quotient identity to express the Pythagorean identity. Cosine squared x plus sine squared x equals 1 is equivalent to cotangent squared x plus 1 is equal to cosecant squared x. So the key is here, look at the cotangent. You got to think about this. How do we get cosine over sine? Because that's what cotangent is. We want to do that. So if we look at the original one here, if we multiply everything by 1 over sine squared. I'm not multiplying by sine x. I'm multiplying by sine squared x because these are all squares. So I multiply everything by sine squared x. So that you can see here, cosine squared x over sine squared x. Yeah. Sine squared x over sine squared x, and this is just 1 over sine squared x. Okay, let's see what happens. So cosine squared x over sine squared x is cotangent squared x. Yeah, that makes sense. If you look at these ones, the sine squared x's, they're the same, and you're dividing by the same thing, so it's just 1. Oh, that's nice. And this one, 1 over sine, is just cosecant. So yeah, it rearranges into that. So the three forms of the Pythagorean identities are, and this is on your formula sheet. There they are right there, right? Get used to seeing them. Now, the nice thing about these is they can be rearranged any way you want. So look at this first one here. So we have cosine squared x plus sine squared x equals 1. You can rearrange it. To get sine by itself, you move the cos squared x to the other side, it becomes negative. Useful to know because that's what we're going to do when we're doing some proofs, which is example number 2. Prove that 2 secant squared x, theta, right, careful it's theta this time, not x, is equal to this and this. Okay, so what are you going to work? Left side, right side? Well, I'm going to work the right side, and sometimes it's hit and miss. It's trial and error in a lot of ways. You'll get better as you go through some of these things. But remember, you can work both sides if you need to. Let's see what I did over here on the left. I took out the 2. Yeah. Oh, sorry. I changed secant to 1 over cos. Yeah, and then I multiplied by 2, so 2 over cos squared theta. Okay, that works. Now look over here. Oh boy, we have this plus this. So how do we do that? Well, we have to find a common denominator. So our common denominator is 1 minus sine theta and 1 plus sine theta. So what you do is you multiply both sides. So this one, it's missing the 1 plus sine theta, and this one's missing the 1 minus sine theta. Okay, so multiply by that. So then we can combine the bottom, right? And what do we do on the top? Well, 1 times 1 and 1 times sine theta. Oh yeah, that's just distributive property. Plus 1 minus sine theta. Okay, that's distributive property. Now, look at the bottom here. 1 minus sine theta times 1 plus sine theta. That's a difference of squares, right? If we multiply the 1 and we multiply the sines, and the two center terms are going to cancel out. So we end up with 1 minus sine squared theta. What about the top? Well, sine theta minus sine theta, they just cancel each other out, right down to 0, and then 1 plus 1 is 2. Okay, keep going. So 2 over 1 minus sine squared theta is, what can we do with this one? We can rearrange this whole thing. Remember we said on the last page, you can rearrange that, and it rearranges to cos squared theta. So we have 2 over cos squared theta. Oh, look, is that what we had over here? Yeah, left side equals right side, right? they just take practice is all you got to do, and try to work through it. And what happens is sometimes you'll start working through and trying to change it to one thing. You'll end up back at the beginning again. We'll stop and rework it through. Okay, last example. Example number 3. Prove that secant squared x minus cosecant squared x equals tan squared x minus cotangent squared x. Wow, there's a lot of squares, a lot of weird things in there. What do you want to work? Left side, right side? Well, we're going to work left side in this case. Secant, rearrange that. That's just 1 plus tan squared x. Cosecant, that is cotangent squared x plus 1. Okay, and we put in brackets there because you got to watch. That negative is going to apply here, isn't it? So we end up with 1 plus tan squared x. Oh, yeah, that's negative cotangent squared x. Why is this negative here? Well, because that negative applies to that one, so it's minus 1. What happens to the ones? They're gone. So we're left with tan squared x minus cotangent squared x. Wait a sec. That's what we have on the right-hand side. Wow, that was a really easy proof. So sometimes these proofs are going to take a bit of time, and sometimes they're going to take very little time at all. Now you can practice those ones.